Hello statistics students, my name is Emigh, and this video is our discussion on section 4.3, complements and conditional probability. Complementary events are denoted as a capital A and a capital A with the bar over top, okay? So when you see that notation, think, okay, that is the complementary event of A. A with the bar over top, or A naught, we read it like that, A naught, is the complement of A and is often read not A. The probability of an event and its complement sum to the number 1. All right, this equation right here tells us that the probability of A occurring plus the probability that A will not occur equals 1. Now, we know that only certain events will equal 1, which means that it is certain that either A will occur or A will not occur. Here's a Venn diagram kind of explaining that for us. Here's our probability that A will occur in yellow, and in pink is our probability that A will not occur. So if you add those together, the yellow circle and the pink square minus the circle, it equals 1, the entire diagram, the entire population, the entire probability. If we take this first equation, let me erase some of this. If we take this first equation here and we subtract the probability of A from both sides of the equal sign, we end up with this here. The probability that A will not occur is 1 minus the probability that A will occur. So you'll see the equation used in both formats. A lot of times if you're asked, calculate the complement, you'll pick up your calculator and you'll type 1 minus, and then you'll subtract out the probability that A will occur, and that'll give you your complement. It is impossible for an event and its complement to occur at the same time. So A cannot occur, event A cannot occur and not occur at the same time. All right, let's look at an example. If the probability of an event is 0.87, what is the probability of its complement? What do you think? If you said 0.13, you got it right. There are two main ways people go about this. Some of us see the 0.87 and think to ourselves, what else do we need to add to get to a total of 1? And that would be 0.13. Or some of us go about it this way here, which is, what will the complement be if we take 1 minus 0.87? Both ways are correct, just two different ways that people see it. If you're using your calculator, you'll often use this one here, 1 minus 0.87. Another example, a sample of United States adults were surveyed and 20% of them were smokers. Find the probability of one randomly selected U.S. adult not being a smoker. So notice they didn't use the word complement, they didn't use A or A naught. So what's important for us to do is read the question carefully and determine that what they're asking us is to find the complement, so not being a smoker right there. Okay, well, if our probability of not being a smoker is equal to 1 minus the probability of being a smoker, then we would do 1 minus that 20% that are smokers. Careful with the 20%, when you input that there, it goes in as a decimal, and that means that you have a 0.80 probability of randomly selecting one U.S. adult and them not being a smoker. All right, go ahead and pause this video and try this example, please. Welcome back. If you came up with 0.000007, then you got it right. Nice job. That's also 21 over 3 million. And that would mean that the probability of dying in making a skydiving jump is 0.000007. Okay. If you did not get that, let's walk through the solution here. We're being asked, we're doing part A here, to find the probability of a skydiving death, and that is one event, so that's why you see one fraction. Numerator being whatever is considered a success. I know that a skydiving death is not considered a success. Don't think of it like that. It's rather whatever's put in parentheses here is determined to be the numerator or the success in this problem. So our number of skydiving deaths we got from here, 21, and then our total number of jumps we got from here, 3,000. Part B, the probability of not dying when skydiving would be the complement. So you could just do 1 minus the 0.00007 and you'll get the 0.999993, or you can work that out from scratch. The probability of not dying when skydiving, so that's what's now considered a success. The 2,999,979 came from the 3 million minus 21. 3 million minus 21. That's where they got the 2,999,979 from. Okay, and these two events are complementary events. So you can work them out from scratch like that, or you can use the formula for complement to work them out. And notice that they add to 1. If you pick your calculator up and let me erase some of this extra work here. This is A, this is B. If you take your calculator and you do this one here, plus sign this probability here, you will get to 1. And that is because the probability of skydiving death and not a skydiving death are complementary events. The probability of not dying when we make a skydiving jump is 0.999993. All right, let's try this example together. Data from a study of 2 airlines which fly to small town USA are listed in the table here. We have 2 airlines, Podunk Airlines and Upstate Airlines. It looks like Podunk Airlines had 33 on-time flights and 6 late. Upstate Airlines had 43 on-time flights and 5 late. We're asked if one of the 87 flights is randomly selected. Let me pause for a second. I think they're getting the 87 from adding all this up together. That's a total of 87 flights. Find the probability to 3 decimal places that the flight arrived on time, given that it was an Upstate airline flight. Okay, we're going to learn about this word given through example first, through this example here. When a condition is given to us that the flight must be an Upstate airline flight, then it is important that we do not include any of the Podunk airline flights. Given means that part must be true, so don't look at anything else. All right, so looking at the question now, we're finding the probability that the flight arrived on time. Okay, so just focusing on this right here, the Upstate Airlines had 43 on-time flights, and Upstate Airlines had a total of 48 flights. All right, so the keyword given implies that we have a condition, Upstate airline flights, that must be met. The notation for that, you guys have seen before. It's capital P, open parentheses, capital B, given, that vertical line right there is given, capital A, denotes the conditional probability of event B occurring given that condition A is met. Okay, so we're going to set this up with this example. We're being asked to find the probability that the flight is on time given it's an upstate airline flight. You're going to want to practice translating like this here. And it came from right here, on time, given upstate airline flight. So you see this portion right here goes right into the parentheses after the capital P. I'm going to erase this. There's a lot of clutter going on, and I'm going to do it again. On time, given upstate airlines. Same thing matching down here. On time, given upstate airlines. Okay, so on-time flights, there were 43, like we said. Upstate Airlines had a total of 48 flights, and that came from the 43 plus the 5, so a total of 48 upstate airline flights. I know it's tempting to use the 87 as the denominator, but the 87 includes Podunk airline flights, so we have to literally cross it out if you're able to, or just cover with your finger, or just mentally block it out if you have to. Whatever follows the word given is the only thing we should be looking at and including in our calculations. 43 divided by 48 is approximately 0.896. So we have a 0.896 probability that that a flight arrived on time, given that it was an upstate airline flight. All right, I want you to try this one now, okay? Pause the video and try this one, please. Welcome back. Let's see how you did. If you interpreted this as probability of upstate airline given a late flight, your numerator of upstate airlines late flight would be 5 divided by a total of 11 late flights. 5 divided by 11 is 0.455. If you got that, great job. If not, no problem. Let's figure it out right now. Okay, upstate airlines, given it's a late flight. So I have to cross out everything that's not a late flight. So we cross out this column. Maybe now you're seeing where that 11 and the 5 came from. Okay, so we're just looking at late flights. Upstate airline had 5 out of the 11 late flights. So if you didn't get it first, hopefully you're starting to see it now. We have another example. So if you're just starting to catch on, this is a perfect example. Go ahead and pause this video now and try this example, please. Welcome back. Let's see how you did. We want to translate this into this form here. Probability that the subject uses drugs given positive drug test. That would make our numerator 44. Our denominator is 143. That reduces to 22 over 67. We weren't asked to round, so we'll leave it as that exact fraction because as a decimal it will repeat. Okay, if you got that, nice job. If not, no problem. Let's go through this together. Okay, our given condition is that we have a positive drug test. So we're going to cross out everything else. Okay, positive drug test, that first column, so we're going to cross out all of this stuff here. Okay, this tells us our numerator. So we have 44. And then our denominator is all the positive drug tests, which 44 plus 90 is 134. All right. 3 adults are randomly selected without replacement from the 247,436,830 adults in the U.S. Assume that 11% of adults in the U.S. use drugs. Find the probability that all 3 selected adults use drugs. Okay, I'm using this example to introduce to you the 5% guideline for cumbersome calculations. Okay, the guideline says when sampling without replacement, that's key, and the sample size is smaller than 5% of the population. So let's check out our sample size. 3 adults out of this population. Let me do some work here. 3 divided by that population size, 6830 equals, let me get my calculator real quick. We've got 3 divided by 247, 436, 830. Okay, that is, well, it's giving me the answer in scientific notation, 1.21, so on, times 10 to the negative 8th. On my calculator, it looks like capital E minus 8. That would be 0 point, and then I need 7 zeros. 1, 2, 3, 4, 5, 6, 7, 2, 1. Okay, so that right there then turned into a decimal, into a percentage is 1, 2. So now I'm talking 0.1234521%. Okay, let me explain what's going on. We surveyed 3 out of this many people. 3 out of this many is approximately 0.0000021% of the population. Okay? So way less than 1% of the population. I'm going to erase all this right now, but what I need you to keep in mind is that we surveyed 3 out of this many, which is less than 1% of the population. Okay, let me erase all this clutter. Okay, when sampling without replacement and the sample size is smaller than 5% of the population, treat the selection as independent. Okay, it's called the 5% guideline for cumbersome calculations. So let's make sure we meet these guidelines. Without replacement, check right there. Less than 5%, definitely we surveyed only 3 out of that many, which is less than 1% even. And that means we can treat the selection as independent. Okay, 5%, less than 5% sampled without replacement, independent. Okay, so what that means to us is that when solving this, or when addressing this question now, find the probability that all 3 selected adults all use drugs. That would look like this: probability of all 3 adults use drugs. That would mean that the first person we surveyed uses drugs, and the second person surveyed uses drugs, and the third person surveyed uses drugs. And then there's no adjustment to make or anything to subtract out because we're saying independent. So this person, independent of that person, independent of that person. So don't worry about making adjustments given like the first person was already pulled from the population and then the second person was already pulled from the population. Just go ahead and treat this as 3 separate fractions, which we actually don't even have the fractions. We have the percent. We have 11%. So we have to enter that as a decimal. Probability that first person uses drugs is 0.11. Multiplied by probability that second person uses drugs is 0.11. Multiplied by probability that the third person uses drugs is 0.11. In mathematics, we have a notation called exponential notation. Whenever we're multiplying the same thing together many times, we write the base once, and then we write that number of times as an exponent. It doesn't seem necessary because it's only 3 here, but if we had a larger number like 50, then we would want to write 0.11 risen to the 50th. And if we use our calculators and we type in 0.11, 0.11, and then use that up caret, it's in the first column under the word clear, and then the number 3, and hit enter, that's where you get the 0.001331 from. Okay, so in a population where 11% of adults use drugs, your probability of selecting 3 random adults and all of them using drugs is 0.001331. Very close to nothing. And that's not that one of those people doesn't use drugs, it's that all 3 do not use drugs. Okay, and there is that written down for us. Okay, this video is starting to get a little bit long, and we're just about to introduce a brand new concept of at least one. So I'm going to stop this recording now, and the next video on this section will pick up on this slide here. So thank you for joining me. My name's Jami Emigh, and I will see you soon.